Good afternoon. Now we are going to see Engineering Mathematics 1 2301 MA 104. In this unit, differential calculus, we are going to see the topic as circle of curvature. We can define a circle of curvature in such a way that the circle which touches the curve at a point T and whose radius is equal to the radius of curvature is known as circle of curvature, and its center is known as the center of curvature. Radius of curvature already we know very well. If the radius and the radius of curvature are equal, provided if the circle touch the curve at a point T and also its center is known as the center of curvature. The equation of the circle of curvature is represented by the equation x minus x bar the whole square plus y minus y bar the whole square equal to rho square. Already we know that x bar comma y bar represents the center of curvature and rho represents the radius of curvature. Before moving to the actual equation, first we have to define what is x bar and y bar. X bar and y bar already I told you that it represents the center of curvature and they are defined by x bar is equal to x minus y1 divided by y2 into 1 plus y1 square, and y bar is defined by y bar is equal to y plus 1 by y2 into 1 plus y1 square. Under this, first we are going to see a curve y square equal to 12x. We are going to find the circle of curvature under the point 3, 6. So find the circle of curvature of the parabola y square equal to 12x at the point 3, 6. Okay. Now the curve is given by y square equal to 12x. For the purpose of finding y1 and y2, first we have to take differentiation with respect to x. Y square equal to 12x. In the left hand side, simply we are having y square. If you are taking the differentiation of y square is 2y. Differentiation of y square is 2y. Into differentiation of y is dy by dx equals 12 into differentiation of x is 1. 12 into 1, 12. So 2y into dy by dx is equal to 12. In the next step, we have to bring 2y into the right hand side. Then we have dy by dx is equal to 12 divided by 2y, that is 6 by y. That is y1, which is also represented by dy by dx. Dy by dx is nothing but y1. D square y by dx square, the second derivative is represented by y2. So y1 is equal to 12 divided by 2y, which is equal to 6 by y. But in the problem they are given that at the point 3, 6 they are given. That means x value can be taken as 3 and y value taken as 6. So 6 divided by 6, we are getting y1 equal to 1. y1 is dy by dx. The value of y1 is given by 1. Next, we need to find the second derivative y2, that is d square y by dx square. The d square y by dx square can be split as d by dx of dy by dx. d by dx of dy by dx. Already we found that dy by dx value is 6 by y. Before applying the point 3, 6, we are having y1 as 6 by y. So d by dx of 6 by y. We need to take the differentiation with respect to x of 6 by y. Before taking the differentiation, we have to bring y into the numerator. So we are getting d by dx of 6y inverse. 6y inverse. If you are taking the differentiation, 6 into minus 1 into y power minus 1 into dy by dx. That is, here simply we have to apply the very basic formula of differentiation. D by dx of x power n is equal to n into x power n minus 1. We can apply the very basic first formula of differential calculus. So we have minus 1 into y power minus 1 minus 1. The actual formula is n into x power n minus 1. So minus 1 into y power minus 1 into differentiation of y can be taken as dy by dx. So for Framing the equation of circle of curvature, first requirement is to find y1 at the point 3 comma 6. Just now we found that y1 equal to 1. Second step is to find y2. Next we are going to apply the point 3 comma 6 in y2. Our next aim is to apply the point 3 comma 6 in y2. That is in d square y by dx square. In page 3, if you are simplifying, you are getting minus 36 y power minus 3 is our y2 value. That is the second derivative. That can be written as minus 36 divided by y power 3. That is, we have to bring y power minus 3 into the denominator, then minus 36 by y power 3. Here also we have to apply the given point 3 comma 6. Then we get minus 36 divided by minus 36 divided by y cube, that is 6 into 6 into 6. Okay. So we are getting y2 equal to minus 1 by 6. So the first thing we have to find the value of y1 at the point 3 comma 6 is minus 1 and y2 value is minus 1 by 6 at the point 3 comma 6. Next, for framing the circle of curvature equation, our next requirement is to find x bar. Already we have seen that the formula for finding x bar, one component, x component of the center of curvature is represented by x bar. X bar can be defined as x bar is equal to x minus y1 by y2 into 1 plus y1 square. So x bar is equal to x minus y1 by y2 into 1 plus y1 square. Okay. So x value is given in the problem itself, 3 comma 6 they are given. So at the point 3 comma 6 they are given. That's why we can take x here 3 x value as 3 minus of y1 by y2. Y1 we found that minus 1 divided by y2 is minus 1 by 6 into 1 plus y1 square. So 1 plus 1 square. So if you are simplifying, you are getting the x bar value as 15. Next, we need to find the value of y bar. Y bar can be defined by y bar is equal to y plus 1 by y2 into 1 plus y1 square. So, y value is given by 6. So, 6 plus 1 by minus 1 by 6 into 1 plus 1 square. We are simplifying and we get y bar equal to minus 6. So, what are the things we are already find? Y1, y2, x bar, y bar. The last requirement for framing the circle of curvature equation is radius of curvature. Radius of curvature formula we already know very well. 1 plus y1 square whole power 3 by 2 by y2. Y1 value just now we found that 1. So 1 plus 1 whole power 3 by 2 by minus 1 by 6. And if you are simplifying, 6 into 2 power 3 by 2 here. 2 power 3 by 2 can be written as 2 power 1 into 2 power 1 by 2. This is nothing but 2 power 1 into root 2. So minus 12 into root 2. Radius of curvature is minus 12 into root 2. The last part of the problem is to frame the equation of circle of curvature. From the beginning itself, we write the equation x minus x bar the whole square plus y minus y bar the whole square equal to rho square. And then x bar value is 15, y bar value is minus 6 and rho value is minus 12 root 2. So x minus 15 whole square plus y plus 6 whole square is equal to minus 12 root 2 whole square. So the equation of circle of curvature for the given curve is x minus 15 whole square plus y plus 6 whole square is equal to 144 into 2, 280 is the required equation of circle of curvature. Once again, we have to go through the previous part. So, this is the equation of circle of curvature. X minus x bar the whole square plus y minus y bar the whole square equal to rho square. In this case, x bar is equal to x minus y1 by y2 into 1 plus y1 square. And y bar is equal to y plus 1 by y2, 1 plus y1 square and rho equal to 1 plus y1 square whole power 3 by 2 by y2. The problem is given by y square equal to 12x. We can take the first derivative with respect to x, that is dy by dx, and apply the point 3 comma 6. We found that y1 equal to 1 and taking the second derivative with respect to x, d square y by dx square, and apply the point 3 comma 6, we found that y2 equal to minus 1 by 6, and x bar and y bar are also founded by 15 and minus 6, and rho value is minus 12 root 2 by using the formula 1 plus y1 square whole power 3 by 2 by y2. Finally, we can frame the equation as x minus x bar the whole square plus y minus y bar the whole square equal to rho square. Second problem is also under the circle of curvature for the hyperbola. Find the circle of curvature of the hyperbola xy equal to 12 at the point 3 comma 4. So better we have to bring this x into the right hand side. Also we can keep as it is and then differentiation is that is also correct. So for our convenient we can bring x into the right hand side and the given equation can be modified by y equal to 12 by x. Taking the first differentiation with respect to x, then we are getting differentiation of y in the left hand side is dy by dx. Simply we are having y in the left hand side. So differentiation of y is dy by dx equals, before differentiation we have to bring x into the numerator. We are getting 12 x power minus 1. And if we are taking the differentiation, we are getting minus 12 x power minus 2. Because here also we are using the same basic formula of differentiation as d by dx of x power n is equal to n into x power n minus 1. Using that formula, we can write it as y1 equal to minus 12 x power minus 2. Again, we have to bring x power minus 2 into the denominator. We are getting y1 equal to minus 12 by x square. So this is our y1 value. The next stage we have to apply the point 3 comma 4 in dy by dx. Then we are getting dy by dx at the point 3 comma 4 can be written as minus 12 by x square, that is minus 12 by 3 square minus 12 by 9 minus 4 by 3. Taking the second derivative of minus 12 x power minus 2. Already we found y1 as minus 12 x power minus 2. After applying the point 3 comma 4 only we are getting the value minus 4 by 3. Okay. So in the next stage, we have to find d square y by dx square at the point 3 comma 4. So d square y by dx square is minus 12 x power minus 2. Differentiation of x power minus 2 is minus 2 x power minus 2 minus 1. The same formula d by dx of x power n equal to n x power n minus 1. So minus 12 into minus 2 x power minus 2 minus 1. So we are getting 24 x power minus 3. That is our y2 value d square y by dx square can be written as 24 by x cube. Next we find the value of y2 at the point 3 by 3 comma 4. So 24 divided by 3 cube we are getting 8 by 9. So y1 value, what is the y1 value we have? Minus 4 by 3, and then y2 value at the point 3 comma 4 is 8 by 9. Next we need to find the value x bar. X bar is equal to x minus y1 by y2 into 1 plus y1 square. Already we know that the value of x and y are given by 3 comma 4. So we can substitute x value as 3 and we found the value of y1 as minus 4 by 3 and y2 as 8 by 9. We can substitute all those things in the formula of x bar, that is the center of curvature order x component. In the next step, if you are simplifying, you are getting x bar value as 43 by 6. Similarly, we need to find the value of y bar for the purpose of circle of curvature. Y bar is equal to y plus 1 by y2 into 1 plus y1 square. We know the value of y2 is 8 by 9. Y value is given in the problem itself 4. So 4 plus 1 by 8 by 9 into 1 plus y1 value is minus 4 by 3 the whole square. After a very basic simplification, we are getting y bar value is 57 by 8. So what are the requirements for circle of curvature? Y1, that is dy by dx, y2 d square y by dx square, x bar comma y bar, as well as the last step is to find the radius of curvature by using the formula 1 plus y1 square whole power 3 by 2 by y2. Applying y1 y2 value, then we are simplifying to get the radius of curvature value as 125 by 24. Then the last step is to frame the circle of curvature equation by using the above entries. Then x minus x bar the whole square plus y minus y bar the whole square equal to rho square. X bar value is 43 by 6 and y bar value is 57 by 8. So x minus 43 by 6 whole square plus y minus 57 by 8 whole square equal to 125 by 24 whole square.